Howdy folks, welcome back. We are now in section 4.8 of our pre-calculus class, applications and models. So we're going to be applying all the stuff we did in previous sections and solving right triangles. So for this section, in all cases of right triangles, we will identify the angles of the right triangle by A, B, and C, all capital letters, where C is always going to be the right angle. And the lengths of the opposite sides of the triangle will be lowercase a, b, and c, where lowercase c is the hypotenuse. So you can kind of see what we have here. Now in this case, they want you to identify the sine, cosine, and tangent values for each acute angle of the following right triangle. So they gave us two sides, we're missing our third side, and so first thing we should do is get that third side. So we're going to need to use the Pythagorean theorem. So we can quickly do that. Now again, lowercase a is going to be opposite capital A, and lowercase b is going to be opposite capital B. So just kind of keep it straight and orderly. So we'll plug in those values and then start simplifying it. So let's get our calculator out here. So 7.1 squared, 50.41, squeeze that in here, and 9.7 squared, 94.09. Okay, so we're going to have to add those up. So let's add 50.41 to that. So 144.5. And so C should be the square root of that. So 12.02. Now, as far as the number of decimal places, you can see that our other two sides have a decimal point of one decimal point. Now, so if we wanted to round this to 1 decimal point, we could, but we can also leave it that way if we want. All right, so now we have our third side, 12.02, we should be able to find our sine, cosine, and tangent values for each acute angle. So we're going to want the sine of A. So the sine of A should be the opposite over the hypotenuse. So 7.1 over 12.02. Now we can get the decimal value of that. And as far as the number of decimal places, again, we want to be careful to have enough. So I would recommend at least 4 decimal places, because if you round it off to too few, you're not going to get as accurate of an angle. So 0.5907 if we rounded it to 4 places. So the cosine of A should be our adjacent over hypotenuse, so 9.7 over 12.02. So let's get the decimal value of that. So we can see it's 0.8069, so if we round that to 4 places, 8070. And last but not least, the tangent. Tangent is opposite over adjacent, so 7.1 over 9.7. So 7.1 divided by 9.7. So 0.73195. Looks like we can round that to 20. All right, so we have our sine, cosine, tangent for angle A. Now we're going to do the same thing for B. And we'll skip this last step of just doing those decimals. So looking at angle B, so we want the sine, so we need the opposite over a hypotenuse. So 9.7 over 12.02, which would be this decimal here. So remember, these always have that relationship, that co-function relationship. So we're probably going to get 7.1 over 12.02. And then our tangent is just going to be the reciprocal. So 9.7 over 7.1. And there we have it. So all they wanted was the value. So they just want this decimal value, and that's it. Now, if we wanted to go a step further, which we do, we can actually find the angles using our calculator. So find angles A and B in exercise 1. Now, what's nice about this is that we have a lot of choices that we could go from to get our angles. Now, what I would recommend is not to use any trig values that use this value of C, because we had to round it. Instead, I would try to use a trig function that had these two values, because those are given and solid. So the only one that has that, though, is the tangent. So since we know that the tangent of A is equal to 7.1 over 9.7, we can use the inverse function of tangent. Now, we talked about inverses back in chapter 1, but even tangents and cotangents and all them, they all have inverses. So the way you would do that on your calculator is to find the button for tangent and look above it. And usually they'll have a tangent with a -1. Now, the other fancy way to say that is arctangent. So those mean the same thing, but this is obviously a little bit more compact. So we're going to use tangent -1. And what we're going to want to do is use that 7.1 over 9.7. So let's take a look. So on your calculator, you can see right above it, there's that tangent -1 that we're looking for. So what we would do first is we want to first get this decimal in our calculator. So 7.1 divided by 9.7 equals, so there's our decimal. But now if we hit second tangent, that's going to give us the angle. So you can see 36.2. So this is going to be 36.2 degrees. Now, once you have one of your acute angles, you can get the other one pretty quickly, because remember, those two angles are going to be complementary. So we can easily subtract this from 90 to get B. Or we could also use an inverse trig function. Now, so we know that the tangent of B is 9.7 over 7.1. So let's just verify. So let's see what we get. 9.7 divided by 7.1 equals that. And so now if we'd hit second tangent for that one, looks like we get 53.8. And what happens when you add these two angles together? We do get our 90 degrees. So that's always going to be the case with those acute angles. They should always add up to 90. So that's always a nice little check. So, all right, well, let's stop here, and then we'll pick up more applications and more specifics in the next video. See you soon.